How we can get benefit? How we can get benefit from the zeros that are located on the critical line in Riemann hypothesis for quantum computing? If you imagine that one of the main problems in quantum computing is the length of the coding, is the length of the data, is the length of the amount of the data that's available. And to ensure that the piece of data is connected to the next piece and has relation to it, and it's the continuity of the first piece, then we can use zeros as and for that purpose. For example, we have a piece followed by another piece. To make an and connection, it means that this piece and that piece are one continuation of the puzzle. So to ensure that, we should have specific zeros for that, which are not part of the coding. And it just gave a clue that we have continuation for the previous information. And that can be ensured by the zeros which are present on the critical line. So each one of these zeros are known, and each one of them has its equation and can be plotted and can be mathematically calculated. So when we apply this zero during the sequence of the codes, it shows the way for the code, and it shows smoothen the process and make debugging, for example, easier. And even we can, through these zeros, we can use it as a these zeros during the sequence of the codes can be used as a nest or as a place for manipulation of the text. Imagine that this code of 1 and 0 is available. When we reach to the specific point, we apply one of these zeros followed by another piece of code, then another zero. Imagine that the first zero in the critical line will be followed by the second zero, then the third zero, fourth zero, and we know that we have a lot of zeros of that, and can be arranged in this way to make it easy for quantum computing to find its way and to make a unity in the quantum computing. And for example, imagine that we have a big piece of code followed by another big one. We can put an end between them, one of these zero, according to the sequence. When you end to the end of the information, you don't need to write another code. You just start from one, put another one. So it's impossible that in one sequence of information we have two ones. So a new one indicate that we have a new coding, and you start the new coding and end it. As you end, you start another one. That means a new coding for another information. By this way, we reduce the space which is needed for saving data for quantum computing.